Hello, this time we are going to take a longer time to discuss about the factors affecting rate-off reaction. Different chemical substances have different chemical properties. As a result, different chemicals have different reaction and occur at different rates. There are four factors affecting the rate of reaction. The first one is size of reactant, which is related to the total surface area. Second is the concentration of the solution. The third one is the temperature, and the fourth one is the presence of catalyst. The rate will change, but the amount of product you obtain will not. First factors which affect the rate of reaction is size of reactant. Size of reactant is closely related to the total surface area. Okay, let's say you have a wooden block with the size of the width, length, and the height is 3 centimeter. Now we are going to calculate the surface area of the one exposed surface area here is equal to 3 times 3 is equal to 9 centimeters square. Now we must calculate how many exposed surface area this wooden block have. Okay, 1 on the top, 2 at the bottom, 3 on the side, okay, 4, 5, and 6. So exposed surface area is equal to 6. Therefore, total surface area for this wooden block is equal to 9 cm square times 6 is equal to 54 cm square. Alright, let's say I cut this wooden block into two. Now we have two separate blocks. Okay. From the same wooden block, saya potong dia jadi dua. Now sekarang dah jadi. Dia punya width, length and height dia berbeza lah. Okay, width dia 1.5, length 3 cm and the height is 3 cm. Let's say we are going to calculate the exposed surface area yang sebelah sini. So which mean 1.5 times 3 is equal to 4.5 cm square. Jadi kita nak kira berapa exposed surface area yang bersaiz 4.5. So kita ada 1, 2, bawah, 3, belah sana 4. So exposed surface area bersaiz 4.5 ada 4. Jadi total mesti darab dengan 4 is equal to 18 cm square. Next, we are going to calculate the surface area at this side. Okay, 3 times 3 is equal to 9. And then satu blok ni ada berapa? 1, 2. Ada dua exposed surface area yang bersaiz 9 cm square. So the total surface area with the size of 9 cm square is equal to 18 cm square. Okay, so kita tambahkan kedua-duanya ni, 18 tambah 18 is equal to 36. Alright, okay, 36. So kita ada dua blok. Okay, satu total surface area adalah 36. So kita ada dua, that's why kita kena darabkan 2. Now dia jadi 72 cm square as compared to the first one yang tadi ni. Okay, satu wooden block tu dia punya total surface area 54 saja. So bila kita bahagi kepada 2, so dia punya size berkurangan, the total surface area semakin besar. Let's say saya potong lagi, so dia dapat 4. There are 4 smaller wooden blocks here. Okay, from the same wooden block kan. Now kita dapat 1.5 cc dia punya width, dia punya height 1.5 and dia punya length 3 cm. Now we are going to calculate the surface area yang bersaiz yang saya tunjuk anak panah ni. So 1.5 times 3 is equal to 4.5. So untuk satu blok ni ada berapa surface area bersaiz 45 cm square? 1, 2, 3, 4. Okay, so therefore total surface area bersaiz 4.5. 4.5 times 4 is equal to 18 cm square. Alright, next we are going to calculate the total surface area yang sebelah sini pula. 1.5 times 1.5. Okay, so 2.25. Satu wooden block ni yang kecil ada dua exposed surface area bersaiz 2.25. So times 2 is equal to 4.5. So total surface area untuk satu wooden block yang kecil is equal to 18 plus 4.5. Okay, And then kita ada 4 blok, darabkan dengan 4, dapatlah 90 cm square, which is the smaller the particle size, the larger the total area, surface area. This is the reaction between hydrochloric acid and calcium carbonate, also known as a marble chips. So, are we going to do here? Okay, this is the setup of apparatus in the reaction between hydrochloric acid and calcium carbonate. So, one must have a conical flask with a stopper, and the stopper is connected to a delivery tube, which is connected to a measuring cylinder. The measuring cylinder is inverted into a basin of water. So, apa yang kita buat adalah, first, we add dilute hydrochloric acid into a conical flask. Yang inilah dilute hydrochloric acid. Second, okay, the reaction between calcium carbonate and hydrochloric acid produce calcium chloride, water and carbon dioxide. So, the function of the measuring cylinder here is to collect the production of carbon dioxide. So, we must use a measuring cylinder supaya kita tahu berapa volume. Okay, we cannot use a test tube or a boiling tube sebab test tube and boiling tube is not a measuring device. Okay. Okay. This is capillary tube ni tadi. Okay. Okay. Macam mana kita nak invert measuring cylinder ni? First, basin ni, okay, must be filled with water, and after that, our measuring cylinder tu pun kita kena isi dengan air. And then we must invert it into a basin. Jadi bila kita invert tu, the measuring cylinder is also full with distilled water. Okay. Right after that, we add calcium carbonate into the conical flask, and subsequently we close the conical flask. Okay, sebab once the calcium carbonate masuk dekat dalam hydrochloric acid ni, dia akan react lah, the close react. Okay, throughout the experiment, we will see there's a bubble of produce, bermaksud ada reaction berlaku antara calcium carbonates. Okay, when there is a bubble, bermaksud ada gas produce lah. Gas tu dia akan flow out through the capillary tube dan dia masuk dalam air. Bila gas masuk dalam air, dia ada bubbles. Okay, subsequently, the level of the water here will decrease. Sebab apa dia berkurangan? Because the carbon dioxide will replace the water. Okay, that's why air itu berkurangan. Okay, so kita akan measure volume of carbon dioxide produced ni daripada measuring cylinder ini. Alright. And then kita mesti measure, mesti ada masa, dan kita mesti setkan at time interval tu berapa banyak gas yang produce. Okay, lepas reaction tamat, kita akan repeat gunakan different size of calcium carbonate. Katakan tadi kita gunakan crush. Okay, now we replace the crushed calcium carbonate with the powdered calcium carbonate, and then we observe dia punya changes. Okay, so this is the two result of experiment yang kita plot. First, kita gunakan larger chip. The second one, kita guna smaller chip. Okay, this is the graph for the rate of reaction. Okay, graph of volume of gas produced in centimeter cube against time in second. So kalau tengok based on the graph kat sini, kan, kita boleh tentukan which experiment has higher rate of reaction and then which experiment has lower rate of reaction. Based on the graph, kalau kita lukis gradient, okay, gradient atas, gradient bawah. So gradient for the small chip is steeper than the gradient for the large chip. So we can say that rate of reaction for the second reaction is higher than the first one. Okay. Alright, and this reaction, these two reactions produce the same amount of gas. Okay. Sebab kita kata kita tukar faktor tidak memberi efek kepada amount of the product. Okay. Tapi dia hanya beri efek kepada rate of reaction dia. Okay. Okay, for the bigger size of chip, reaction completed in 5.7 minutes. Lambat lah. Okay, while smaller size of chip completed in 4 minutes, lebih awal. So bermaksud reaction lebih cepat. Okay, so this result shows that the rate of a reaction increases when the size of reactant is smaller because surface area of a solid reactant is bigger for the small chips. So we can conclude that a smaller size of chip causes an increase in the surface area of the solid, so the rate of reaction will increases. This is because more surface area of the particle will be exposed to the other reactant, so there will be more frequent and effective collisions, increasing the rate of reaction. Okay, this is explosive combustion. Explosive combustion occurs when there are many fine particles in the air. So fine particle ni kita nak relatekan dia dengan size of particle lah kan. Right, many industrial process such as metal working, coal mining and flour milling produce very fine and tiny particles. Therefore, these particles have a very large surface area and are combustible in air. Even a small spark may cause them to ignite, and since the surface area is so large, the rate of reaction can be incredibly fast. Hence, they are explosive. Methane gas mixed with air in coal mines can also form an explosive mixture. So, fine particle ni lebih reaktif lah. Okay, lebih cepat bertindak. Second factors that will affect the rate of reaction is concentration of the solution. Okay, the concentration of a solid in solution can be changed by adding a solvent. Solvent biasanya distilled water lah, or adding a solute. Okay, when we add more solvent, so the concentration will become low. But when we add more solute, the concentration of the solute become increase. Increase in the concentration of a solution, the rate reaction will increase. This is because there will be more reactant particles in a given volume, allowing more frequent and effective collision per second. Therefore, it will increase the rate of reaction. Okay, this is the reaction which relates to the effect of concentration. Okay, reaction between sodium thiosulfate solution with dilute acid. Okay, we must have conical flux. Okay, conical flux tu kita akan letak dia dekat atas X mark. X mark tu kita lukis atas satu kertas. Okay, alright. Kemudian we measure 5 cm³ of dilute hydrochloric acid in a measuring cylinder. Subsequently kita tambahkan, tuangkan. Okay, yang ni kita dah buat tadi lah, draw cross on a piece of paper and put it underneath the flask. And then kemudian kita subsequently we add acid into the flask and immediately start the stopwatch. Okay, maksud bila once the material semua bercampur, reaction akan start lah. So stopwatch tu mesti dimulakan. Okay, look down at the cross from above and stop the stopwatch when the cross can no longer be seen. So as long as the cross mark tu boleh kita nampak, kita tak boleh stop lagi the stopwatch. Okay, bila mark X mark tu dah hilang daripada pandangan kita, dan kita boleh stop reaction tu. Dan kita akan catat berapa masa yang diambil untuk certain concentration of sodium thiosulfate. Masa yang diambil untuk X mark tu disappear. Okay. So kita we will repeat using different concentration of sodium thiosulfate solution. Okay, mix a different volume of sodium thiosulfate solution with water to dilute it. Maksudnya bila sodium thiosulfate, okay, ini amount of sodium thiosulfate, ini amount of water. So kat sini dia punya concentration of sodium thiosulfate is the lowest one ya, paling cair di sini. Ni paling pekat lah. Okay. When it involves concentration, okay, one must use this formula to calculate the concentration. Okay, the formula is M1V1 is equal to M2V2. So the capital M symbol here means the molarity or concentration of the solution, and the capital V here means the volume of the solution. Okay, M1 is the original concentration of sodium thiosulfate solution. V1, the volume of sodium thiosulfate solution used. Okay, yang berapa kita nak ambil lah. M2 is the new concentration yang kita inginkan. And V2, the volume of the dilute sodium thiosulfate solution yang kita ambil untuk jadikan dia volume yang concentration yang baru. Okay, let's see, we have a list of experiment. Okay, this is the volume of sodium thiosulfate solution used in experiment 1 until experiment 5. So when we are changing the volume of the sodium thiosulfate solution means we are adjusting their concentration as well. Okay, let's say the M1 here is the original concentration of the sodium thiosulfate is equal to 0.2 mole per centimeter cube. And then the volume of the sodium thiosulfate is 45 centimeter cube. Okay. Alright, let's say kita gunakan formula M1 V1 is equal to M2 V2. So M1 dengan V2 ni, the red one yang warna merah ni, saya buat ni, adalah nilai yang kita tak akan ubah lah. Okay, kalau you nak kira nilai yang awak tak akan ubah. Okay, but V1 ni adalah volume of sodium thiosulfate, volume yang baru. Okay, yang awak nak. Okay, katakan eksperimen pertama, we use 45 cm3 of sodium thiosulfate. For experiment number 2, we use 40 cm3 of sodium thiosulfate and so on. So now M2 ni kita tahulah berapa concentration yang baru. Okay. So katakan kita masukkan M1 0.2, V1 ni kita masukkan 40. Okay. And V2 is tak berubah kan, saya cakap tadi 45. Right, ni V2 45. Jadi concentration yang terbaru untuk eksperimen number 2 for the sodium thiosulfate is equal to 0.18 mole per centimeter cube. So concentration dah berubah. Jadi bila awak masukkan nilai-nilai ni dalam formula, awak akan dapat concentration yang beginilah. Okay. So the concentration as the volume of the sodium thiosulfate decreases, so the concentration of sodium thiosulfate is also decreases. So this is our table of data. Okay, yang tadi itulah eksperimen 1, 2, 3, 4, 5. Eksperimen 1, volume of sodium thiosulfate 45, and then eksperimen 2, 40, eksperimen 3, 35, 30 and 25. Okay, volume distilled water ni berubah. Sebab apa dia berubah? Untuk cukupkan total volume dia 45. Okay, katakan yang ni kan 45. Okay, and volume of sulfuric acid, kita mesti tambah sulfuric acid kan, sebab dia memang react dengan sulfuric acid. The volume of the sulfuric acid does not change. Okay, kita tak berubah, sama sahaja. And the total volume untuk keseluruhan sodium thiosulfate dengan acid adalah 50, semuanya 50. Jadi katakan kat sini volume of sodium thiosulfate 40, untuk cukupkan dia 45, so distilled water berbanyak ke tambah 5 sahaja. Dan tambah dengan sulfuric acid 5, jadi total volume untuk keseluruhan mixture of the solution is 50. Experiment 3, we are using 35 cm3 of sodium thiosulfate. So untuk cukupkan dia 45 cm3, kita tambah dengan 15 cm3 of distilled water. And the volume of the sulfuric acid adalah sama. Okay, ini concentration yang dah berubah tadi lah yang kita kira from the previous slide. Okay, and then ni adalah the time taken yang awak kena ambil for the X mark to disappear from view. Okay, from the data on the previous slide, of course you can plot a graph of volume of gas produced. Sepatutnya time taken for the X mark disappear lah sepatutnya kan. Okay, cuma kat sini nak terangkan based on the graph. Okay, compared to a reaction with a reactant at a low concentration, the graph line for the same reaction but at a higher concentration has a steeper gradient at the start and becomes horizontal sooner. Okay, yang ni lah. Okay, the purple graph line yang ni, okay, is the high concentration of solution used, and the green one is lower concentration. For the purple one, the gradient is steeper than the green one. Okay, so kita boleh cakap eksperimen yang menggunakan high concentration of solution has high rate of reaction. Okay, this is because there will be more reactant particles in a given volume in high concentration of solution, allowing more frequent and effective collisions, increasing the rate of reaction. Factor number 3 is the effect of temperature towards the rate of reaction. Okay, increase in the temperature, the rate of reaction will increase. How? Okay, this is because the particle, when we increase the temperature, the particle will absorb more energy and the particle will have more kinetic energy, okay, than the required activation energy. Therefore, there will be more frequent and effective collision per second, which increase the rate of reaction. Okay, ini setup of experiment untuk effect of temperature. Okay. Dilute hydrochloric acid heated up to accept a temperature using water bath. Okay, katakan suhu bilik tak sampai 30 kan, so kita nak panaskan asid sampai 30, so kita letak dalam water bath dan kita panaskan. Okay. Add a strip of magnesium and start the stopwatch. Okay. Bila kita dah setkan temperature of the hydrochloric acid solution tadi, kita nak 30, dah sampai 30, kita akan terus masukkan magnesium strip and dalam masa yang sama we start the stopwatch. Okay. During the reaction we will see a bubble gas produced. Okay. Okay, stop the time when the magnesium fully dissolved. Habis dia dissolve, dah tak ada bubbles, masa reaction has completed. Okay, kita akan stop dan kita akan adjust lagi temperature for the hydrochloric acid to become higher ke macam mana kan. Okay, alright. This is what you get. Okay, with an increase in the temperature, the rate of reaction will increase. Okay, how? Yang ni lah. The blue line here is the higher temperature and the green one is the lower temperature. This is because the particle will have more kinetic energy than the required dissipation energy. Therefore, more frequent and effective collision will occur, increasing the rate of reaction. Okay. Rate of reaction does not change their amount. Okay, amount dia masih sama. Okay, kedua-dua reaction stop pada total mass yang sama. Tapi the rate of reaction dia berbeza. Okay, gradient dia. Now, effect of presence of catalyst in the rate of reaction. Okay, catalysts reduce the activation energy as they create alternative pathway requiring lower activation energy, allowing more effective and frequent collision. Katakan ini adalah activation energy yang sebenar yang perlu dicapai oleh reactant particles, okay, untuk dia dapat effective collision. But when we apply a catalyst in the reaction, dia punya activation energy akan rendah lah. Okay, so dia akan rendah. Alright. Okay, so bermaksud dia mempercepatkan reaction tu lah. Okay. So this show that when a catalyst is used, the rate of reaction will increase. This is how we gonna conduct experiment with the effect of catalyst. Okay. Set out of experiment here we have a conical flask. Okay, ada stopper kat sini, stopper tu connect dengan delivery tube and then disambung kepada measuring cylinder lah. Bila ada measuring cylinder kat sini bermaksud akan ada gas yang terhasil nanti yang kita nak ukur, kita nak measure. Okay. We add hydrogen peroxide into a conical flask, use a capillary tube, ini saya sebut dah tadi. Okay. Lepas tu kita akan masukkan a chosen catalyst, any catalyst lah. Okay. For example, here manganese 4 oxide. Kita masukkan dalam conical flask yang ada hydrogen peroxide tadi, and kita akan tutup dia punya conical flask ni. Okay, measure the volume of gas produced in a fixed time using the measuring cylinder. Okay, experiment will be repeated without the catalyst of manganese 4 oxide and compare result. Okay, yang first kita guna catalyst, yang second kita jangan letak catalyst. So kita tengok berapa lama masa yang diambil for the reaction to complete. Okay, how catalyst affect the rate of reaction? Okay, macam ni lah ya. Using a catalyst will increase the rate of reaction because catalyst will provide an alternative pathway yang ni. Okay, requiring lower activation energy. This is the actual activation energy. Tapi bila masukkan catalyst, dia punya activation energy direndahkan. So more colliding particles will have the necessary activation energy to react. So this will allow more frequent and effective collisions, increasing the rate of reaction. So kita ada banyak guna perkataan effective collision sebab kita tahu for a reactant particles to react, okay, particles must collide satu benda. Collide tu mesti guna dengan energy yang optimum supaya berlaku effective collision. So effective collision tu lah yang akan menyebabkan reaction berlaku. Kalau tidak, bila dia collide biasa, dia hanya akan bounce back. So nothing happen. So we must have effective collision for the reaction to occur. Example here, Reactive metals such as potassium react with water to release hydrogen gas. The chemical reaction is calcium plus water produce calcium hydroxide and hydrogen gas. Two experiments are carried out to determine the rate of reaction between 0.7 gram of calcium and 200 centimeter cube of water at different temperatures. Experiment 1 is carried out at a room temperature. In experiment 2, the temperature of water is increased by 10. So katakan experiment 1 room temperature 30, so experiment 2 dia punya temperature jadi 40 lah. So the diagram below shows the graph of volume of hydrogen gas against time for experiment 1. Okay, inilah. Right, volume of gas against time in second, volume of gas in centimeter cube. Soalannya, what is the total volume of hydrogen gas produced in experiment 2? Explain your answer. So macam kita kata tadi, okay, changing the factors does not change the amount. Jadi, total volume of hydrogen gas untuk eksperimen 2 masih sama dengan eksperimen 1, which is 420. Explanation yang tadi itulah. Okay, does not change the product, does not change the amount, but only change the rate of reaction. Question number 2, what is the effect of temperature on the rate of reaction? So, as the temperature increases, the particles will absorb more heat energy, and the particles, the kinetic energy of the particles increases, okay, move even faster, and then it will have more frequent effective collision, and the rate of reaction will increase. Next question. Gastric is caused by the production of too much acid in the stomach. Doctors use antacid tablets to neutralize the acid in the stomach. Table 7.7 shows the time taken by each antacid tablet to react completely in excess hydrochloric acid under different conditions. So the condition kat sini ada dua lah, concentration dengan temperature. Alright, why the time of reaction is different for experiment 1 and 2? So tengok experiment 1, time taken for experiment 1 is 120, but experiment 2 is 60. So experiment 2 reaction dia berlaku lebih pantas daripada eksperimen 1. So kita tengok apa yang berbeza. Okay, volume of hydrochloric acid sama. Concentration for experiment 1 is 1.0 mole per decimeter cube of hydrochloric acid solution. Eksperimen 2 dia gunakan 2.0 concentration mole per decimeter cube of hydrochloric acid. Temperature for both experiment is the same, which is 30. So dia tanya why the time of reaction is different for experiment 1 and 2, because experiment 1 use lower concentration of hydrochloric acid, while experiment 2 use high concentration of hydrochloric acid. So experiment 2 has higher rate of reaction, because reaction for experiment 2 is faster than experiment 1. Okay, why is the rate of reaction for experiment 4 is higher than experiment 2? Okay, experiment 4, experiment 2. Alright, time taken for experiment 2 complete is 60, which is longer than experiment 4, which is where it takes only 30 seconds. So kita tengok apa yang berbeza. Volume of hydrochloric acid sama, concentration of hydrochloric acid sama. Temperature used in experiment 2 is 30, but temperature used in experiment 4 is 40. So therefore, kat sini reasonnya because experiment 4 use higher temperature as compared to the experiment 2. Alright, that's all for the factors which affect the rate of reaction. Okay, thank you. Lepas ni kita akan tengok topik collision theory pula.